With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us start with our question. In this question, there is a LCR circuit which is given, which is connected to a battery of EMF E and internal resistances R. Now after a long time, so initially capacitor was uncharged, so it is given. Now after a long time, what will happen? So after a long time, capacitor behaves as an open circuit. That means there is no current which would be going into this branch. This we should remember. Now for the inductor would behave after a long time. It would be behaving as a conducting wire. Conducting wire. Okay, that means there won't be any potential drop in the inductor. So if we just construct our circuit, so what will be the case? For example, if some amount of current, let's say I value comes I amount of current comes here, so some part would be going into this branch and then some part would be going into this branch. No current would be going across the capacitor, okay, because it would be behaving as an open circuit. Now the current which is coming here, so some part of the current would be going here and some part of the current would be going here. Finally they all would be combining, and then the current would be equals to I. Now, if we just draw our circuit diagram into this case, we just draw a representative figure. So let's say, so this and these would be in parallel, and then they would be connected with the resistance R in series. Okay, so we just make the resistances. So this is one of the resistance, this is another resistance, and this is another resistance. This resistance is R. Now this resistance is 2R, and this resistance is 2R. So they both are in parallel. Okay, now from here we just draw our this resistance R. So this is our resistance R, okay, and then we would be having this internal resistance. We just represent this resistance, internal resistance, to be separately from the battery. So this is our resistance, internal resistance, and this is our resistance 2R. This one resistance 2R, okay, and here we are having the battery. So this is our battery. Now if we just combine this, so it would be like this, okay. So this is a simplified figure. Now we just mentioned that this is EMF is E and resistance is R. Now if we just see our figure, so these and these are in parallel. So for the parallel system, if the resistance are equal, so the combined resistance would be halved. So it would be 2R divided by 2. That means for this part, resistance would be equals to R. So R and R combined, it would be equals to 2R. So we just draw another just diagram. So we just draw another diagram. So here the combined resistance would be equals to what? So this is R and this is also R, and they both in series. So resistance would be added. It would be 2R. Now here resistance is already 2R. Sorry, here the resistance is already 2R. We just write the value as 2R. And then we just construct our this battery, and the resistance, the internal resistance is smaller, like this. Okay, the battery is EMF E and the resistance is R. Now we can see that now this 2R, this 2R, these are in parallel. So the effective resistance would be equals to what? So they are equal. So it would be 2R divided by 2. That means R. Now this R and this R, they would be in series. So we can say that our R equivalent for the circuit would be R plus R. That means equals to 2R. So our current from the battery, it would be equals to E divided by R equivalent, which is 2R. So it would be E divided by 2R. We just write this E divided by 2R. That means, let's say this value is the value I. Okay, now what we need to find, we check. Now we need to find what is the current through the inductor and also the charge stored in the this capacitor, and also the potential difference across the terminal of the battery. Now once we know the value of this current, now here we can see that this resistance and this resistance is equal. So the current would be halved. So it would be I by 2 here, and here the current would be equals to I by 2. Now inductor is connected where? Inductor is connected with this 2R. Now here we come. Now the current which is going here, it is equals to here it is equals to I by 2. Okay, now here what would be the current? We can see that this is 2R, this is 2R. So current would be divided. So the current which would be going into this branch, it would be equals to I divided by 4. And this 2R is connected to the inductor. So we say that current through the inductor would be equals to I divided by 4. So what is the value of the current through the inductor? I through the inductor, this is equals to I by 4. And what is the value of I? It is equals to E by R. Now if you put this result into it, it would be E divided by 4R. Sorry, 8R. So if we check for the first option is the correct option. Now also we need to find what is the charge stored in the capacitor. Now the charge stored in the capacitor, Q value is equals to C into delta V, potential difference across the capacitor. Now the potential difference across the capacitor would be equals to potential difference across this resistance R and across this resistance 2R. So we say that capacitance value C, then potential difference across the resistance this R. Now this R is having a current of I by 2. So we say that potential difference would be I divided by 2 into R plus. Now this 2R has a current of I by 4. So we say that the potential drop would be equals to I by 4 into the resistance value would be equals to 2R. Okay, so if we solve this, then it would turn out to be C into I into R. We can put the value of I, which is equals to E divided by 2R. If we put this into here, so R and R would be cancelled. It would be just CE divided by 2. So which is the correct option? CE divided by 2. So CE divided by 2, that means C is the correct option. B would be wrong. Now also we need to find what is the potential difference across the terminal of the battery. Now it is very simple. Once we know the EMF and the current, we say that potential difference across the battery is equals to E minus I into R, the internal resistance. E value is given as to be this E minus current value we have calculated E divided by 2R, and the resistance of the battery is capital R. So it would be equals to this R and this R would be cancelled. E minus E by 2, that means E divided by 2. So if we check this option, so this option would be given as E by 4. So this is wrong. So the correct option are A and C. Hope you understood this solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.